In this video, we're going to learn how to multiply polynomials. Now, in arithmetic, when we want to multiply two real numbers, one thing that we can do to visualize the multiplication is to draw a rectangle. For example, if I want to multiply the numbers 4 times 3, what I can do to visualize this product is draw a rectangle which has width 4 and length 3. The product of 4 and 3 would then be the area of this rectangle. And the area here is 12. So the product of 4 and 3 is 12. We're going to use a similar idea to multiply polynomials. For example, let's take the product of the polynomials x plus 5 and 2x plus 3. In our previous video, we learned about like terms. In these two polynomials that we're multiplying, the x and the 2x are like terms, and the 5 and the 3 are like terms. Now, it's tempting to just multiply the like terms and add up the result, but that would be incorrect, and that is a common mistake that a lot of people make. They would try to do the x times the 2x plus the 5 times 3. The result here would give us 2x squared plus 15, but again, this is incorrect. We can't just multiply the like terms and add up the results. Let's try to understand why. Just like before when we were multiplying real numbers, we can visualize this by drawing a rectangle. The width of this rectangle would be x plus 5, but what we're going to do is divide this into two portions, a portion that has length x and a portion that has length 5. So altogether, the width is x plus 5. The length of this rectangle is 2x plus 3. But we're going to do something similar. We're going to divide this into two portions, a portion that has length 2x and a portion that has length 3. So altogether, the length of that side is 2x plus 3. Now, the product of the two polynomials would be the area of this rectangle. We can find the area of the entire rectangle by finding the areas of each of the small rectangles within it. In the top left, we have a smaller rectangle that has width x and length 2x. So the area there would be the product of x and 2x, which is 2x squared. For the top right triangle, we have width 5 and length 2x. So the area there would be 5 times 2x, or 10x. In the bottom left rectangle here, we have width x and length 3. So the area of that rectangle would be x times 3, or 3x. Finally, the bottom right rectangle has width 5 and length 3, so the area there would be 5 times 3, or 15. So the product of the polynomials x plus 5 and 2x plus 3 is the area of the entire rectangle, which is the sum of the four smaller rectangles. So that's going to be 2x squared plus 10x plus 3x plus 15. If we combine the like terms 10x and 3x, we end up with 2x squared plus 13x plus 15. So this is the actual answer to the product x plus 5 times 2x plus 3. If we compare this to the incorrect answer that we got previously, we notice that there are some similarities. We have the 2x squared and the 15, but notice that we also have an extra 13x. So next we'll talk about how to get the correct answer without resorting to drawing a rectangle each time we want to multiply polynomials. To multiply polynomials, it's important to remember the distributive property for real numbers. The distributive property tells us that if I have three numbers labeled a, b, and c, then a times b plus c is equal to a times b plus a times c. So what's happening here is that the a here is multiplied to each of the terms within the parentheses, the b and the c. This rule is going to apply to polynomials as well. So to multiply two polynomials, we use the distributive property, then we combine the like terms. Let's look at some examples. In my first example here, I have the polynomial 2x multiplied to the polynomial x squared minus 3. To perform this multiplication, I'm going to take the 2x and I'm going to distribute it within the parentheses. So I would take the 2x and multiply it to the x squared and also to the negative 3. So I have that this is equal to 2x times x squared plus 2x times negative 3. When I multiply 2x to x squared, I'm going to have 3 factors of x, so this becomes 2x cubed. When I multiply 2x to negative 3, multiplying the 2 and the negative 3 together gives me negative 6, and then I still have a factor of x. So I get 2x cubed minus 6x as my final answer. In our next example here, we have the polynomial 4x squared multiplied to the polynomial 3x squared minus 5x plus 2. This time, within the parentheses, I have 3 terms added together: the 3x squared, the negative 5x, and the 2. This time, when I apply the distributive property, I'm going to take the 4x squared, I'm going to multiply it to each of these 3 terms. So we'll have 4x squared times 3x squared plus 4x squared times negative 5x, and then plus 4x squared times 2. Now let's simplify each of these products. Here, 4x squared times 3x squared, we can multiply the coefficients together to get 12, and then I'll have 4 factors of x, which gives me x to the 4th. When I do 4x squared times negative 5x, again, I'll start by multiplying the coefficients together. 4 times negative 5 gives me negative 20. Then I collect all of the factors of x. I have x squared times x, which gives me 3 factors of x, or x cubed. And then lastly, 4x squared times 2, multiplying the 4 and the 2 together, that gives me 8, and then I still have an x squared. Looking at these terms here, I notice that I don't have any like terms, so there's no way that I can simplify this any further. So 12x to the 4th minus 20x cubed plus 8x squared is my final answer. In our next example here, we have the polynomial 3x minus 2 times the polynomial 4x plus 5. One thing to note is that when your polynomial has 2 terms, sometimes it's referred to as a binomial. So 3x minus 2 has 2 terms, so we can call it a binomial. 4x plus 5 also has just 2 terms, so we can also call it a binomial. So here we have a product of 2 binomials. To do this multiplication, one approach that we can take is take the first polynomial, 3x minus 2, and distribute it within the second parentheses. So I take 3x minus 2 and multiply it to the 4x and also to the 5. What we can also do is take the second polynomial and distribute that inside the first parentheses. So I take the 4x plus 5 and multiply it to the 3x and also to the negative 2. So let's take the second approach. I'm going to take the 4x plus 5 and multiply it to the 3x. So that's going to give me 3x times 4x plus 5. And then I'm going to take the 4x plus 5 and multiply it to the negative 2. That's going to give me negative 2 times 4x plus 5. As you can see, we still have products that we need to compute. To simplify this first group, 3x times 4x plus 5, I'm going to need to use the distributive property again. I'm going to take the 3x and multiply it to the 4x and also to the plus 5. The second group, again, I'll need to use the distributive property. I have the negative 2 here, which I need to distribute to the 4x and also to the plus 5. In our first group, we have 3x times 4x plus 3x times 5. And in our second group, I need to distribute the negative 2, so I'll have plus negative 2 times 4x plus negative 2 times 5. As you can see, the product of 2 binomials is a little bit complicated, but luckily there's an acronym to help us remember things that we need to multiply. When we multiply 2 binomials, we use the FOIL method, F-O-I-L. The F stands for first, meaning we multiply the first terms of each of the binomials together. Here we have 3x times 4x. The O stands for outer, meaning we multiply the outer terms of the binomials together. In this case, that's the 3x and the 5. The I stands for inner, meaning we multiply the two inner terms of the binomials together. And then the L stands for last. We multiply the last terms of the binomials together. So again, this method is called the FOIL method, F-O-I-L, and they're acronyms for first, outer, inner, and last. And that will help you remember the terms that you need to multiply together. So let's now simplify what we have. 3x times 4x, multiplying the coefficients together gives me 12, and we have two factors of x, so that's 12x squared. When we multiply the outer terms together, 3x times 5, I can combine the 3 and the 5 to get 15, and then I have a factor of x. Next, I have negative 2 times 4x, multiplying the negative 2 and the 4 gives me negative 8, and then I have a factor of x. And then lastly, we have negative 2 times 5, or negative 10. Notice here that we have like terms. The 15x and the negative 8x are like terms, which means that we can combine them together. So combining their coefficients, 15 minus 8 gives me 7, so in the end I'll have 7x. So the result is 12x squared plus 7x minus 10. So that's the product of the two binomials. Let's look at more examples. In this next example, we have another product of two binomials. We're going to use the FOIL method to multiply these binomials. Remember that the acronym is F, O, I, and L. So let's do the multiplication. F stands for first. We're going to multiply the first terms of the binomials together. That's the 5x and the negative x. So for first, we have 5x times negative x. Next, we have O. O stands for outer. So the outer terms of the binomials are 5x and 8. So we have plus 5x times 8. The I stands for inner. The inner terms are the plus 2 and the negative x. So we have plus 2 times negative x. And finally, the L stands for last. The last terms are the plus 2 and the plus 8. So in the end, I have plus 2 times 8. All we have to do now is simplify. First, we have 5x times negative x. Negative x can be thought of as negative 1 times x. So multiplying the coefficients together, 5 times negative 1 gives me negative 5. And then I have two factors of x there, so I have negative 5x squared. Next, 5x times 8, multiplying the 5 and the 8 together gives me 40, and then I have a factor of x. Next, 2 times negative x, well, 2 times negative 1 is negative 2, and then I have a factor of x. Lastly, we have 2 times 8, which is 16. Next, we'll combine the like terms 40x and negative 2x to give us negative 5x squared plus 38x plus 16. So that's our final answer. In our next example here, we have 2x plus 3 times 2x minus 3. Again, we're going to use the FOIL method. F for first, O for outer, I for inner, and L for last. The first terms of the product are 2x and 2x. So I have 2x times 2x plus the outer terms are the 2x and the negative 3. So I have plus 2x times negative 3. The inner terms are the 3 and the 2x. So I have plus 3 times 2x. And finally, the last terms are the plus 3 and the minus 3. So I have plus 3 times negative 3. Simplifying this, we get 4x squared minus 6x plus 6x and then minus 9. We have like terms negative 6x and plus 6x, which cancels out. So our result is 4x squared minus 9. Let's do one last example. So here we have the binomial x minus 2 times the polynomial x squared plus 2x plus 1. Unfortunately, we don't have a product of two binomials here, so we can't use the FOIL method. We'll just have to multiply this out using the distributive property. So what we can do is take the polynomial x squared plus 2x plus 1 and distribute it within the first parentheses. So I can take this polynomial and multiply it to the x and multiply it to the negative 2. So multiplying the polynomial to the x, we get x times x squared plus 2x plus 1. Then multiplying the polynomial to the negative 2, we have negative 2 times x squared plus 2x plus 1. At this point, we need to use the distributive property again. We need to distribute this x into every term within the parentheses. So I'll distribute this to the x squared, the 2x, and the plus 1. And I need to repeat this for the second group. Take the negative 2, distribute to the x squared, the 2x, and then 1. So in our first group, we have x times x squared plus x times 2x plus x times 1. In our second group, we have negative 2 times x squared plus negative 2 times 2x plus negative 2 times 1. So let's simplify this product. X times x squared gives me 3 factors of x, so I'll have x cubed. Then x times 2x would be 2x squared. X times 1 would just be plus x. Next, we have negative 2 times x squared, so that's negative 2x squared. Negative 2 times 2x gives me minus 4x. And then lastly, negative 2 times 1 gives me negative 2. Notice here we have some like terms that we need to combine. We have the 2x squared here and the minus 2x squared here, which will cancel out. And then we also have a plus x and a minus 4x, which can be combined to give me negative 3x. So overall, this product is x cubed minus 3x minus 2. And that's our final answer. So that's it for this video. In our next video, we'll talk about factoring polynomials.